Chapter 15, example 3. What we have here is another adding problem. It's adding 4 8-bit unsigned binary values, and it generates an 8-bit unsigned binary output. So the issue is if I add 4 different 8-bit values, I could end up with a 10-bit value. This problem specifies it only has an 8-bit out. So there's a real important issue here, but we'll go ahead and start from the normal place. This is unsigned binary, and so we've designed some validity checking circuits for signed binary, but this is unsigned binary. And so all we have to do for unsigned binary is to look at the carryout. So if any of these additions generate a carryout, that means the value on the sum output of the ripple carry adder is not correct. So this is similar to the last problem in that I only add 2 things at a time, so I'm going to meet multiple ripple carry adders in this problem. Essentially what I'm going to do is add A and B and add C and D and add those results together, and I will have 3 additions. If any of those generate a carryout, then the final answer is not correct, and we'll go from that. Let's do this. It's like I said, it's very similar to the last problem in that it has 3 ripple carry adders. So here is the problem that will do my addition for me, and what I need to do is check to see if any of these generated carryout. So what I need to do for this problem is include the carryout in here. When we're working with signed binary numbers, we generally ignore the carryout, but now we need to consider the carryout. If any of these carryouts is a 1, then the circuit's not valid. Another way to say that is these 3 carryouts need to be 0 for it to be valid. And so what I'm going to do is use an AND gate with bubbles on it. So this means 0 is the active state, and this is going to be my valid output, which is the same as this. And what I'm going to do is simply connect these carryouts to that AND gate. It's not really an AND gate, it's actually the AND form of a NOR gate. And so this works. So if any of these inputs are non-zero, the valid is going to be 0. If all 3 of these carryouts are 0, this is going to be a 1. And that is my entire circuit. So the issue here is what controls this circuit. So if you look at the circuit, there's no choice on the output. The output is always just sort of fixed based on the inputs. In that sense, essentially there's no control. There's nothing controlling this circuit, because the circuit is always doing the same thing. The previous circuits kind of made a choice of either outputting one thing or another. This is not the case with this circuit.